Hey everyone, get ready because today we're diving into something pretty wild. Something that even blew Einstein's mind,
Yeah, we're talking quantum entanglement.
which, by the way, he called spooky action at a distance. So that should give you a sense of what we're dealing with here.
It's really a whole other level of interconnectedness, something that seems impossible based on how we normally think about the universe.
Right. And the really crazy thing is, it's not just some theoretical physics puzzle anymore. We've been digging into this because of the 2022 Nobel Prize in Physics, which actually highlighted just how much this spooky action is already driving a whole wave of new technology that's going to touch all of us.
I mean, think about it. Quantum computers able to solve problems in minutes that would take today's computers, billions of years to crunch through.
It's mind-blowing.
Or how about communications so secure that our current encryption methods would look like kid stuff?
Goodbye, hackers. Right.
Exactly.
But we're getting ahead of ourselves. Let's back up and explain what entanglement really is. One of the articles we read uses a really interesting example. Two balls, imagine one black, one white, somehow linked in this weird quantum way.
And that's where our regular, everyday way of thinking about the world just completely breaks down.
It's like we're entering a whole other dimension of reality.
Exactly. So picture this. You pick one of these balls without looking at it, right? And then you send the other one off to me, let's say, across the planet. Now, normally we'd each have a 50-50 chance of ending up with either the black or white ball, right?
Yeah, that makes sense.
But here's where quantum mechanics throws us a curveball. Because it's not just that we don't know the color until we look, it's that before anyone looks, each ball is existing in this blurry state of being both black and white at the same time. This is what they call superposition.
Okay, wait, hold on. So it's only when one of us actually looks at our ball that it sort of decides what color it's going to be?
Exactly. And get this, the moment you look at your ball, it instantly determines the color of mine, even though we could be light years apart. It's like they're having a secret conversation at a speed faster than light.
No wonder Einstein found that so spooky. That whole idea of two things separated by such a massive distance still somehow being connected. But how do we know this isn't just some mathematical trickery, some quirk of the equations? How can we be sure that it's actually real?
Well, that's where this brilliant physicist, John Bell, comes in. He actually figured out a way to test whether this whole spooky action thing was, a real phenomenon or just some weird math problem.
Oh, so there was a way to actually put this to the test in the real world. I'm curious, how did they pull that off?
Okay, so Bell came up with these things called Bell inequalities. It's kind of complicated to wrap your head around, but basically imagine there are these ground rules, these Bell inequalities, that would have to be true if there was any kind of hidden information going on behind the scenes in these entanglement experiments.
So like a set of rules for how weird things are allowed to get in the quantum world.
Exactly. If the universe was playing by those rules, then the results of these experiments would have to fall within a certain range. But here's the thing. Quantum mechanics, specifically how entanglement works, completely throws those inequalities out the window.
Whoa, so it's like entanglement is breaking the universe's speed limit or something. That's wild. But we're talking about actual experiments here, right? Not just like theoretical calculations on paper.
Absolutely, real experiments. And those experiments are what earned Clauser, Aspect, and Zeilinger the Nobel Prize. Each one of them built on the work of the others, pushing the boundaries of what we thought was even possible.
Okay, let's dive into those groundbreaking experiments. First up, what did Clauser bring to the table?
Clauser was the first one to actually design an experiment based on Bell's inequalities. He used photons, which are basically particles of light that can also be entangled, and he focused on their polarization. You know how light waves can vibrate in different directions?
Yeah, like polarized sunglasses only let light through in a certain orientation, right?
Perfect example. So Clauser managed to show that the polarization of two entangled photons were linked even when they were miles apart, which directly violated Bell's inequality. It was a huge deal, the first truly convincing proof that Einstein's spooky action might actually be real.
That's incredible. But I'm guessing some people still needed more convincing.
Scientists are a skeptical bunch, right?
Always got to double check their work.
You're absolutely right, and that's where Alain Aspect comes in. Aspect took Clauser's experiment and made it even better, addressing some of the loopholes that other scientists had pointed out.
Loopholes like what? What were people worried about?
Well, some people thought that maybe there was some hidden communication happening between the measuring devices themselves, which could have messed up the results. So Aspect designed his experiment so that the measurements on those entangled photons happened so fast and were spaced so far apart that there was no way any signal could travel between them without breaking the speed of light.
So Aspect basically shut down the idea that entanglement was just some kind of error in the experiment, that he was the real deal.
Exactly. His work provided even more proof for entanglement and how it breaks those Bell inequalities. But it doesn't stop there. Anton Zeilinger, he took entanglement to a whole other level. He was the first to experimentally demonstrate entanglement swapping.
Entanglement swapping. Okay, now that sounds like some next-level quantum weirdness. What is that?
All right, imagine you've got two pairs of entangled photons. Now, take one photon from each pair and bring them together so they interact in a very specific way. And guess what? The two photons that were never originally entangled, the ones for those separate pairs, they become entangled with each other, even though they've never actually met before.
Hold on, it's like they're switching dance partners in the middle of a quantum party or something. My mind is blown.
Yeah, it's like they inherited the entanglement from their original partners. This entanglement swapping was a massive breakthrough. It basically laid the foundation for even more complex entangled systems, like those quantum networks we talked about earlier.
So to recap, we've gone from this seemingly impossible idea to multiple experiments proving not only that entanglement is real, but that we can actually manipulate it and control it. We've come a long way. But let's bring this back down to Earth for a sec.
Yeah.
This is all super interesting, but how does any of this actually impact, the average person?
That's the really cool part. This isn't just some obscure physics theory anymore. All this spooky action stuff, it's about to change everything, from medicine to communication to like our fundamental understanding of reality itself.
Okay, now you've got my attention. Give me the details. What kind of real-world applications are we talking about? So what you're saying is this isn't just theoretical anymore. This spooky action is actually making its way from, like, labs and research papers into our everyday lives. I got to hear more about this.
Oh, absolutely. Remember those mind-blowing applications we were talking about before? Quantum computing, ultra-secure communication, even, baby steps towards teleportation. It all goes back to these same principles of entanglement.
Okay, so break it down for me. What kind of world-changing stuff can these quantum computers actually do?
Well, imagine a world where diseases that we thought were incurable are, just gone, eradicated.
Yeah.
All thanks to new drugs designed on quantum computers.
Wow. So instead of taking decades to develop new medications, we could be looking at, like, medical breakthroughs happening much, much faster.
Exactly. And it's not just limited to medicine. Think about materials science. We could design materials with, like, properties we haven't even dreamt of yet, all because we figured out how to harness the strangeness of the quantum world.
That's mind-blowing. Okay, what about this super secure communication you mentioned? It sounds like something straight out of a spy movie.
Well, it kind of is, because get this, if anyone even tries to eavesdrop on a communication channel that's using these entangled particles, it actually messes with the entanglement itself.
Really?
Yeah, it's like a built-in alarm system. Just by trying to listen in, they'd be revealing themselves, setting off alarm bells.
So no more hackers stealing sensitive information. That would be huge.
Exactly. And then there's quantum teleportation.
Okay, now we're getting into, like, Star Trek territory, right? Beaming people up.
Not quite yet. Right now, it's more about teleporting information. Remember how we talked about entanglement swapping? It's basically transferring the entire quantum state of one particle to a completely different one, and potentially, like, across incredibly huge distances, instantly.
Okay, so maybe not teleporting a person, but their information. Still, that's pretty wild. What could we even do with that?
The possibilities are, well, kind of limitless when you think about it.
Yeah.
Imagine a world where information could travel anywhere in the universe, instantly. It would completely revolutionize how we communicate.
Wow, we really have covered a lot, haven't we? We started with this concept that seemed utterly impossible that even Einstein struggled with, and now we're talking about technology that sounds like it's straight out of the future. What a journey.
It just goes to show you, the universe is way stranger and way more awesome than we often give it credit for. And by, being open to those mysteries, by asking those what-if questions, it opens up a universe of possibilities.
It really makes you wonder, what other secrets is the universe holding on to, just waiting for us to uncover them?
That's the exciting part. Who knows what amazing breakthroughs are waiting for us on the other side of those discoveries, but one thing's for sure. The future is going to be deeply intertwined with this quantum world, and that's a future I, for one, can't wait to see unfold.
Me too. If this deep dive into quantum entanglement has you curious, don't forget to check out the resources we used, all linked in the show notes.
And never stop questioning, never stop exploring. Who knows what other incredible mysteries are out there, just waiting to be solved.
Until next time, keep those minds curious and keep those questions coming.